Your homework over the weekend asks you to look at a couple of problems, and the first type of problem looks like this. You have 4.3. I think it was several of the odd problems over the first 23 problems. This is number 3. It asks you write the trig functions for the angle that has a terminal side that goes through -1, 2. So visually what that really means is this. You have an angle that starts here at the origin and it turns and it goes all the way there. So this is my actual angle. Something to note about trig functions. Trig functions are called periodic functions because they repeat themselves over and over and over. It doesn't matter how many times around the circle you go, there's only one set of answers. Okay? So in this case, we're going to look at, now I have no idea what that angle is, and I'm not going to be able to figure out what the angle is. I don't care about the angle. I only care about the triangle generated by that particular point. And so one thing we've kind of talked about is the fact that if you have an angle, if I draw the reference angle, okay, the reference angle specifically, you're looking at right here. Okay, that's my reference angle. In other words, what we're doing is we're going to refer to this little triangle that's going to give me information about the bigger theta in green. The best part about this is that if I know theta, if I know the triangle that this little theta makes, then I know what the big theta is. And so it doesn't matter. What are the side lengths of this triangle? This is -1. This is 2. How do we know that? It's literally coordinates. I walked over -1 on the x-axis, and I went up 2, right? So we went -1 this direction, and we went 2 units up this way. So that's literally the distance and direction that we traveled. If we don't know what, it's not a 30, 60, 90 or 45, 45, 90, because if 2 had been the hypotenuse, yes, 30, 60, 90, but it's not. But listen, the angle doesn't matter. You're not going to find the angle. We're not concerned about the angle. What we are concerned with is getting the hypotenuse and then just doing SOHCAHTOA trig functions and telling me all 6 pieces. So goal number 1 is to put the triangle on a coordinate plane, put the angle on the coordinate plane, find its reference angle. Listen to me very carefully. A reference angle is always generated towards, you always draw your triangle towards the x-axis. So if it's down here, you draw it back up. If it's over in the 4th quadrant, you draw it back up. First quadrant, you draw it down to the x-axis. You always draw it towards the x-axis, never the y. So how do we find the hypotenuse? Good. So we have -1 squared plus 2 squared, which gives us 5. So, right? So C, that's equals. C would equal 5. Or square root of 5. So here we have the square root of 5. And the only thing left for me now is to find sine, cosine, or tangent. So we have sine. So when we do this, so look at me for a minute. When you find the sine, cosine, and tangent of this little tiny triangle, it's going to be exactly the same as the sine of the bigger angle. It won't matter. We're going to let the coordinate dictate what the sine of sine is, what the sine of cosine is, and all those things. What's the sine of this this angle? Shh. Good. It's just 2 over the square root of 5. What about cosine? And tangent. Yeah, -2. Let's make it easy. So here we're going to have sine. Let's do cosecant. We'll do secant. and cotangent. Whenever you can simplify, you always simplify. So what would be cosecant? Good. What about secant? Just the square root of 5. And what about cotangent? Good, -1/2. All right, listen. This is very typical. This is a very typical kind of problem. I'll give you a coordinate space or on the coordinate plane somewhere. What that really basically says is, here's your x, here's your y, draw the triangle, find out what the hypotenuse is, and then just do SOHCAHTOA, and that's the whole problem. Let's do another one. Here's a one for you to try. I think this is number 5 from your homework. Notice we're saying try it for the first time, but it was part of your homework. No, you can leave it. Unless I specifically request it, something otherwise, leaving the radical in the denominator for now is okay. Later on, we may decide to change that. But so here's the coordinate I want you to work on this time. So the same problem. I want you to find the sine, the cosine, tangent, all 6 trig functions for the angle, and the angle that we're looking at this time goes from all the way to here. Something that is really useful to understand and kind of checking your work. If you really get into this and really understand what you're doing, this also allows you to shortcut a lot of different things. Okay, so on your coordinate plane, any of your coordinate planes, do this with me. Write these letters: A, S, T, and C. What this represents is the trig functions that are positive in those quadrants. So when I go to look at my sine, cosine, tangent, and all that other stuff, then it should hold true, and it always will. Okay? So, listen. When you're looking at it, you've got A, which stands for all. Since all the x and the y coordinates are positive, okay, they're all positive. So that means there's x and y are both positive. It means all trig functions here are positive. S. Okay, S is sine and its reciprocal are positive. T, tangent, and its reciprocal are positive. Cosine and its reciprocal are all positive. Okay? And so when you go through this, I don't know how you're going to remember this. Most people, all students take calculus or all whatever. That's one of the most common ways of remembering it. Shh.
What is A again?
All, write it down. Okay? All students take calculus if that's how you want to remember it. Or make up your own acronym. Now what we're looking at, go back to the example before. Look up at the top. Look up here. Okay? This is in the second quadrant, right? So sine and its reciprocal are positive, right? So sine is positive and cosecant's positive. But look at the rest of them. They're all negative. Other than the first quadrant, which they're all positive, other than that one, only 2 trig functions will be positive. 4 of them are negative. Okay, the 2 that are positive are determined by these letters that we wrote up here. A, S, T, C. Okay, all students take calculus or come up with something else. Okay, so when you look at that, in this case, which 2 trig functions are going to be positive? Tangent and cotangent. Everything else is negative. Okay, so if we write this out, what's the sine of theta? -1 over the square root of 2. Okay, so let's go ahead and write cosecant out. It's going to just be negative square root of 2. How do we do that? All right. Here's my triangle, right? Look. This is -1. That's -1. Pythagorean theorem tells me that's going to be the square root of 2. So we go back over here. Sine is just opposite over hypotenuse. So the opposite divided by the hypotenuse. And I just flipped it over to get the cosecant. What about cosine? Same thing, because this is what kind of triangle? Good. It's a 45, 45, 90 triangle because that's the only right triangle that both legs are the same number. -1, -1. So this one turns out to be negative square root of 2 as well. What about tangent? And cotangent? There should be no reason for anyone to ever miss its reciprocal. If you got 1, you should always have your trig functions reciprocal because, I mean, they just flipped over. So, be careful. Okay. Any questions on any of those things? What would happen if we went in and instead of drawing the triangle like we did, we drew it like this? We drew it down horizontally. Okay, listen. That will work for this triangle because my sides are effectively the same number. But if it doesn't, opposite and hypotenuse will get swapped. Okay, our opposite and adjacent will get swapped in that case. In this one, it didn't matter because they were the same number. In other cases, don't ever do it this way. This would be a big mistake in terms of your trig functions. Some would work out, some that didn't really matter, and some would definitely be wrong every time. So don't wait around to do it that way. Okay? Let's move on to the next type of question. I'm going to write down a couple of trig functions. I want you to put your calculator away. You can have your unit circle out if you want to. That would help. But no calculators at all, not even the basic ones. I'm not even going to allow them on this part of the test. Okay, nothing. I know you're super excited about those. It's real simple. Not really. Okay, so we're going to write down 5 or 6 problems. I want you to try to do this either using unit circle or using the left-hand rule, or just do it in your head. So cosine of 120. Next one is secant of pi over 3. Sine of 13 pi over 6. Tangent of negative 15 pi over 4. Let's start with those. Take a few minutes. I'm going to let you kind of think through this. Whether you use your unit circle, I know, just go with it. Listen very carefully. Okay? And so, I'm going to talk about a number of things that you can do in terms of trying to get these accomplished by hand. So what you're going to have to do is basically use your unit circle would be one way to do it, or you're going to have to do it by using your left-hand rule, which also is great. Okay, and so 120 is a reference angle for what? And what is that? What is its reference angle, though? Okay? Shh. Some of you still don't get this. So we're going to here's a photo. Okay? So really what you're looking at here is, it's a coordinate. It's going to be x, comma, y. So the x coordinate is going to come from here. The comma is where your finger that put down. And your y coordinate is going to come from all over on this side. So the question is, what does x represent? What does y represent? Well, we said last week that the cosine of the angle was equal to the x, the sine of the angle was equal to the y, and the tangent of the angle was equal to the y divided by the x. All super, super relevant things at this point. Right? And so if we kind of go down over here, if we write this out, what this is saying is we have 1 over 2, comma, the square root of 3 over 2. That's what that says in terms of your left hand. Are either one of those coordinates negative? Which quadrant are we in? Right? 120 degrees is in the second quadrant. So if we draw that picture out, it's right here, right? So the x is negative. So that's my coordinate that matches with 120. I ask you for the cosine of 120. What's the cosine? Negative 1/2, right? What is the x? Right here it is. Cosine of some angle is equal to its x coordinate on the unit circle. What's that? No, because it's x coordinate is negative in the second quadrant. If you put a point in the second quadrant, got to go negative x direction, but positive y direction. So it stays negative from the x, positive for y. Where's pi over 3? Hey, listen. What degree is it? It's 60. So we can actually use the same picture we have up here. Except this time, pi over 3 is in which quadrant? It's the first quadrant. So it's going to get 1/2 square root of 3 over 2. So what is the secant? Isn't it the cosine flipped over? So what's the reciprocal for cosine? It would be equal to 2. Good. All right, sine of, listen, 13 pi over 6. Listen carefully. 13 pi over 6 is an angle that exists when I go further around the unit circle than just 2 pi. So we're introducing a word called coterminal. Okay? So look, the word coterminal means that if you started, watch, please listen. Okay? 13 pi over 6 goes past, right? How far past does it go? And so if I go all the way, if I start here, and I go all the way around, that's 13 pi over 6. So what would be one full circle? 2 pi, right? So if I said 13 pi over 6 minus, what would be 2 pi in terms of sixths? So let's just do that. 12 pi over 6. What does that give me? So this angle is actually pi over 6, or just 30 degrees. So pi over 6 is coterminal with 13 pi over 6. What is the sine of 13 pi over 6? Well, guess what? It's just the same thing as the sine of 30. So what's the sine of 30? Okay, that's equal to 1/2. Okay, hold on, we're not done. What about 15 or negative 15 pi over 4? What is that the same as? So can you tell me in terms of positive angles? What is it?
315 degrees. That's 90 degrees.
Let's look at it here. Okay? So if we have it here, let's draw that. Negative 15 pi over 4, that's almost what? That's almost negative what? It's almost negative 4 pi. So we go, that's 2 pi. I'm right there. So that's where my angle turns out to be. So I went 360 degrees around, and then I went almost all the way around again. So what is the question we want to know is, what is the reference angle?
60 degrees.
So that's going to be pi over 4. How would we know that? It's divided by 4, first of all, so I already know. The question really is which quadrant am I in? Okay? 16 pi over 4 is 4 pi. But I'm 1 pi short of that. So I just go back 1. Or, let's do this. If I add 2 pi, and I add 2 pi again, If you convert that over, I'm going to get pi over 4. So what is the tangent of 45 degrees? 1. Knowing reference angles, knowing reference angles and knowing what coterminal angles are, that's the new part for today's lesson. Okay, your homework is on the board, page 347, 25 to 42 all. We actually did a good number of those today in class.
So, since one short